So I thought I'd record this video and do a walkthrough with you of the quiz I'm going to ask you on Thursday or Monday for purple or white. If you're a remote student, it'll be there in Canvas. And again, though, it'll be timed. You'll only have so long to do it. I'm assuming there's no technology. You're going to be doing this. You can use a sheet of notes that you've created. Of course, I'm going to have a hard time policing that if you're fully remote, but you'll have to sign off saying that that's what you did, and then it's on you. So here we go. So here's an example. I gave you this graph, some things I'm seeing about this. I see a midline already. I see this graph has been shifted up. Some things I'm noticing, it kind of looks like a reflected cosine graph. Starts down here, kind of like back when we did the Ferris wheel problem. Those were always reflected cosines. We could also do it as a sine graph, either shift it right or left or even further left. When I do this, I'll write 3 different versions for this for you. So first off, what's the amplitude? Remember, the amplitude is the distance above the midline, or the other way to do it is how low is it going to how high is it going, and we'll find that difference and cut it in half. So I see it's going from 1, y is 1, up to y is 9, so that's a distance of 8, half of that's 4. So that's my amplitude. Now you could also say, oh, it's gone 4 above the midline, 4 below the midline. That's okay. What's the period? So the period is how long it takes to repeat. So if I treat this as a cosine function, it's kind of easy to see those two peaks are pi apart. Half a pi here, another half a pi here. So that's pi apart. So the period for this is pi. The midline I already mentioned is that dotted line that's going through the middle, and it's halfway between the peaks and the valleys, and that's the line y equals 5. Notice I said y equals 5, not just 5. So now if I had to write a sine graph for this, well, let's see. I'm going to go with a sine graph. My eye kind of jumped to this one, and then I can see, I know it goes like this and then back up, but maybe it'd be better to use this one because then I can see one full cycle of it. And maybe I will do that. Maybe I'll start there. So I see it's been shifted. Left 3 pi over 5, or 3 pi over 4. I know the amplitude is 4. I know the B number is going to be 2 pi divided by pi, because the period is pi, right? So the B number is going to be 2. What else do I know? I know the amplitude is 4 already. So I think we're all ready to roll. So I think I'm going to say f of x or y equals 4 for the amplitude times the sine of the B number is 2. So let me drag this over a little bit here. Of x plus 3 pi over 4. Because it shifted left, we changed the sign. Let's see, and the midline is 5, so plus 5. So that'd be one solution. I could use this point. In that case, the sine graphs being reflected around the x-axis or around the horizontal axis. So it's different. If I were going to go with that point, I would say -4 sine of 2 times x. Now that's shifted left pi over 4, so I would say plus pi over 4 plus 5. If I went with this pi over 4 point, that's shifted right, so I could say pi, and it's not reflected that way, so I could say 4 sine of 2 times x plus pi over 4 plus 5. Any of these 3 work. They're all the same. There's even more possibilities, but that would be, you need something like this. Show me about this level of work in order to get those full 10 points, okay? Because you've done a little bit of the work already up here by identifying these. I want to see the B calculation. How do you get B out of the period? And then the left-right shift, identify that. Okay, so what if I wanted to do next question says, do the same function, treat it as if it's a cosine graph. Well, let's see. So cosine graphs, I know, start from the peaks or the valleys. So if I wanted to go with a cosine graph, I could go with this point here. I could go with this point here. Oh, what's happening? All right, here, am I still recording? Yeah. All right, so I could go with that point, I could go with that point, I could go with this point or this point, and then it'd be reflected right around the x-axis. And the period's the same, the b number's the same, the midline's the same. So all you got to worry about is a left-right shift. Suppose I don't do a left-right shift. Suppose I go with that point there. So that makes it a little easier. I can just say f of x or y equals 4 cosine of 2x plus 5, but I forgot to put a negative there because that's been reflected. You know, normally cosine starts up and then comes down. So this is starting down and going up. So I got to reflect it around the x-axis. So that's a solution. I could say I'm shifting it left pi over 2 and go with that point, in which case I'd write y equals positive 4 cosine of 2 times x plus pi over 2 plus 5. I could go with this point and say 4 cosine of 2 times x minus pi over 2, because it's been shifted right, plus 5. Any of those work. Okay, so that's that first set of questions. Let's see, what else? I don't think I have anything else on this page. Okay, so now I've got to write a reciprocal function for what I have. Now, to me, the easiest one, see how the green function is the reciprocal function? And if I look at that dotted one, that's the original one. I just zoomed out a little bit and made it dotted. I like that. I like that negative cosine one. So the equation I wrote for that was y equals negative 4 cosine of 2x plus 5. Well, to get the reciprocal, the amplitude's the same. It's still reflected, so it's negative, because normally cosine, normally the cosine graph looks like that, and the sine graph, and the secant graph goes like that. And I'm going to use the secant graph because the secant function, because the reciprocal of the cosine is the secant. So all I have to do is replace secant or cosine with secant, and all the other numbers stay the same, and that will graph that green function. If you're going to go with the sine graph, if you go with what? See, what was one of the sine graphs? I think it was y equals negative positive. Let's see. If I went with that point, I think it was negative 4. Actually, no, I got it written down here somewhere. Let's see. One of the sine graphs I used was this one. I said positive 4. Here, since that's the one I wrote down, that's the one I'll use. 4 sine of 2 times x minus pi over 4 plus 5. So if I'm going to use a cosecant graph, I just replace the sine with the cosecant, and everything else stays the same. Okay, so that would be a cosecant. Either this one or some other variation of those will work. You just got to write it. Notice there's no work required, and you get 5 points, you get it right. I don't know why you get partial credit, but maybe, I mean, if you had done this, had used cosine, but had written cosecant and just left that, well, that wouldn't work. So that would be wrong. So hopefully you got that practice, and this is a piece of cake. Okay, so from our work on Friday, let's see, when was that? Friday the 5th, right? We learned the cotangent. Think about the unit circle. That's 0, -1. That's 1, 0. Those are ordered pairs. 0, 1, and -1, 0. We know the cotangent of some angle is equal to the x divided by the y value, or the adjacent over the opposite. And we see that 0 divided by 1 is 0. But 1 divided by 0 is undefined. So there's a vertical asymptote at when the angle's 0. There's another vertical asymptote over here at pi. So we know that vertical asymptotes here. There's also another vertical asymptote right here at x equals 0. And I know cotangent graph looks like something like this. So that's normally, if it's not compressed, I know normally this is pi wide. So just like when we do a sinusoidal, we do 2 pi over the b number. In this case, we're going to do pi over the b number. So pi over 7 is the period. That's how wide it is. So where's the vertical asymptote? Well, we already said that at x equals 0, there's a vertical asymptote because it's not defined there. And then this other line, this other vertical asymptote is the period wide, right? Because it goes from 0 to one vertical asymptote over. So the other vertical asymptote happens, or another vertical asymptote happens at pi over 7. We could say, we could skip the 0, 1 and go from x to x equals negative pi over 7, and that would just be on a different cycle, and I didn't say it had to be in the same cycle, so that would work. Tangent's a little different, so you want to go make sure you take a look just in case I ask you a tangent graph function or tangent equation function. Okay, so the last question on this quiz, and this part of the quiz, is to evaluate a composite trig function that's got a arc inverse trig function embedded in it. So how I showed you how to do this in class, or on the video if you watch that, I can say I'd really want to draw a triangle here that's associated with that inside, so I can get rid of that arctan. So if I know the angle, this angle here is equal to the arctan of 5 over 12, I can get rid of the arctan by taking the tangent of both sides. So the tan of angle y equals 5 over 12. And this is the this is the y over the x, or opposite over adjacent. So this is 5, this is 12. If you do not recognize that this is a Pythagorean triple and that's 13, you could say 12 squared plus 5 squared and take the square root, you'd get 13. Okay, don't always get 13. Sometimes you still have a square root left. As you in that practice, you saw that. So I know I've got all the sides of my triangle filled in. Now I'm asking you to find the cosine of angle y. Well, cosine's x over r, or adjacent over hypotenuse. So in this case, it's going to be 12 over 13. And I'm done. Okay. And that's what I'm going to ask you in the quiz. Now, don't print this, and this can't be a cheat sheet. Or cheat notes. You can use your note packet. You can create one by hand from exercises, but I don't want to see that you've used this practice test as your sheet of notes.